Mathematics is the foundation of physics, helping us understand motion, forces, and energy. This guide explores essential concepts like coordinate systems, trigonometry, geometry, and calculus, showing how they connect theory to real-world applications. 1. Cartesian coordinate system in physics. Have you ever wondered how we identify the exact position of an object in space? The Cartesian coordinate system provides the solution. Imagine two lines that are perpendicular to each other. One is the horizontal axis, known as the x-axis, and the other is the vertical axis, called the y-axis. The point where these two lines intersect is called the origin. It serves as the reference point for all positions, which are expressed using coordinates. For example, if we say the coordinates are 2 and 3, it means the object is 2 units away from the vertical y-axis and 3 units away from the horizontal x-axis. This system is the foundation for physics, allowing us to analyze motion, forces, and fields in a two-dimensional plane. 2. Trigonometric ratios in physical problems. Now, let's talk about trigonometry, the study of the relationships between angles and sides in a triangle. Trigonometry is crucial in physics. It allows us to calculate inclinations, heights, and distances. For instance, the sine ratio helps us determine how high a pendulum rises at any moment. Similarly, the cosine ratio describes the horizontal motion of waves like light or sound. These relationships are also vital in engineering applications such as calculating the forces in mechanical structures and determining stress levels in materials. 3. Geometry in motion and design. Geometry plays a critical role in describing motion and designing physical structures. Consider the shapes we encounter in physics. First, we have the circle. It is commonly used to describe orbits, such as satellites circling the Earth. Second, we see the ellipse. This shape explains how planets move around the Sun, following Kepler's laws of planetary motion. Third, we encounter the parabola. This curve illustrates the path taken by a projectile, such as a ball thrown into the air. These shapes are not just theoretical. Circles and ellipses are used in the design of satellite dishes, tunnels, and even lenses. Parabolas are used to design car headlights and telescope mirrors, ensuring focused light and clear imaging. 4. Slope and equation of lines. Let's move to slopes and linear equations, which are critical in physics for understanding relationships. The slope of a line tells us how steep it is. In a graph showing velocity against time, the slope represents acceleration. Similarly, linear equations allow us to describe the behavior of forces. This simple relationship is vital in analyzing inclined planes and other scenarios where angles and forces interact. 5. Calculus in physics. Physics often deals with quantities that change over time, and calculus provides the tools to analyze these changes. Differentiation helps us calculate rates of change, such as how fast an object is moving, known as velocity, or how quickly the velocity changes, called acceleration. Integration, on the other hand, helps us calculate accumulations. For example, it is used to find the total distance traveled by an object by analyzing the area under a velocity versus time graph. These tools are essential for understanding motion, energy, and forces in physics. From coordinate systems to calculus, mathematical tools form the foundation of physics. They transform abstract ideas into practical solutions for engineering, space exploration, and everyday technology. Thanks for listening. Let's start solving some exciting physics problems together. Stay curious and keep exploring.